mystery of the Challenger Deep. Deep below the warm tropical waters of the Pacific Ocean, there is a dark and almost frozen world, a place so dangerous to explore that we know precious little about it. Finding anything alive there was once believed to be impossible. Conditions are so extreme that even the cells that make up all living things would be destroyed. Bones and shells would simply dissolve. The processes essential to life would come to a standstill. That was until 1960, when a creature was witnessed at the very bottom. The first signs of life had been found. But things got even more strange, because not only was life found at these depths, that life had adapted to here and nowhere else on Earth. Much of what we know about this secretive place comes from rare specimens that have been brought up by remote probes. Strange creatures that have mutated to live in conditions that we still don't fully understand. Removed from their natural environment, they are distorted out of shape, often destroyed altogether, so we can only guess what they should look like and how they might live. The vast expanse of our deep ocean floors is the last unexplored frontier on our planet, waiting to be discovered. I'm James Stewart, and you're watching Astrum Earth. Join me in this video as we take a journey into the deepest of them all, the Mariana Trench. Our journey begins 150 years ago, when the British ship HMS Challenger was nearing the end of a 4-year mission, the first ever mapping of the ocean floors. They had already taken hundreds of soundings, a back-breaking job in all weathers. The picture that emerged was of a featureless surface of mud and silt, around 3 to 4 kilometers below the surface. Alone in the empty ocean, 2,000 kilometers east of the Philippines, they were taking another routine sounding. On this day, however, the lead weight did not touch the bottom at 3 kilometers down, nor at 4 or even 5. It kept lowering into the deep. More rope was added, and still it went down. We can only guess how they must have felt as they tied on yet more rope, and that lead weight kept sinking into the depths. Sailing the high seas in those times was a treacherous ordeal. Crews trusted their faith in traditions and superstitions. Legends told of enormous creatures that rose from the depths. Eventually, the weight hit the bottom more than 8 kilometers down. What they had found is now known as the Mariana Trench, and if they had been just a little further to the west, they would have found the deepest hole on the surface of our planet, the Challenger Deep. 11 kilometers down, Mount Everest would disappear into this hole, and it would keep sinking down 2 kilometers below the surface. The Mariana Trench is vast, a 2,500 kilometer long curved valley on the ocean floor. The scale is hard for us to imagine. Just the Challenger Deep alone, which is only a tiny part of the whole trench, could swallow up 5 Grand Canyons. The Mariana Trench is part of an almost continuous series of unstable and constantly moving chasms in the Earth's crust that encircle the Pacific Ocean. They are matched by a ring of volcanoes known as the Ring of Fire. An astonishing 90% of all earthquakes are caused by movements of this 40,000 kilometer fracture, where rock faces many kilometers deep into the earth grind together and destroy each other. To understand what created this remarkable geological feature, it helps to look first at the Atlantic Ocean. Think of the continents as icebergs, floating on an ocean of magma. Between them is a thin layer of ocean crust. All the continents were once crammed together into one supercontinent that we call Pangaea. The Atlantic Ocean is getting bigger as the Americas move away from Africa and Europe. If the Americas are moving westwards, then they must be getting closer to Asia, making the Pacific Ocean smaller. The Mariana Trench was a vital clue in solving this puzzle. The Pacific Ocean crust flows outwards like a geological conveyor belt. But the Pacific Ocean is getting smaller, so where does all this ocean floor go? It is forced downwards, sinking under the continents around it, returning to the magma, a process called subduction. This is the biggest recycling operation on the planet. The Pacific Plate, 170 million years old, meets the younger, less dense Philippines Plate. This plate simply rides over the older, sinking ocean floor. It is this junction of the towering upper tectonic plate and the sinking Pacific plate that creates the Mariana Trench. This zone of destruction creates some of the geological wonders of the world. Here there are gigantic active mud volcanoes pouring out hydrogen, a volcano that spews out almost pure liquid carbon dioxide, and another has a pool of molten sulfur in its crater. Deep fissures vent columns of boiling water rich in minerals. While fascinating, our interest today is traveling down into the trench itself, then making the most extreme dive of them all into the Challenger Deep. You may think that the Mariana Trench is somehow a freak of geology, an unexpected deep hole. But other trenches around the Pacific are of a similar depth. These rifts in the Earth's crust are constantly changing, and the depression that causes the Challenger Deep is only temporary. It will one day be dragged down into the magma, and somewhere else will become the deepest hole in the planet. There are a lot of problems to overcome to explore such depths underwater, but the biggest is pressure. At this sort of depth, that pressure is unimaginable. It is more than 1,000 times the pressure at the surface, which is enough to destroy most living cells. Even equipment designed to cope with these extreme depths can fail in spectacular fashion. In 2014, an unmanned deep-sea exploration vehicle suffered a catastrophic implosion during a dive into the Chromatic Trench. Amazingly, 2 people managed this crazy descent as far back as 1960. Don Walsh of the US Navy and Swiss oceanographer Jacques Picard made the perilous dive in the Trieste. At a depth of around 9 kilometers, there was an almighty bang, but that didn't deter our intrepid explorers. They didn't notice that one of the thick outer plexiglass window blocks had cracked. It took them nearly 5 hours to reach the bottom. They stayed for a mere 20 minutes before having to make the ascent, which took more than 3 hours. What they achieved was so dangerous that nobody else would make the same descent for another half a century. During that time, nearly 7,000 people climbed to the top of Mount Everest, and 12 people went to the moon. That gives you an idea of just how technically challenging it is to explore these depths. The next manned descent was not until 2012, when James Cameron made the first solo dive. Since then, the number of people to make that short journey has finally exceeded the number of people who have traveled to the moon. Above the surface, there is nothing to see but empty, featureless ocean. Descending into the water, the first thing you notice is quiet and calm. Sunlight floods into the water, the epipelagic zone or euphotic zone, which forms only 2 to 3% of the oceans but supports life everywhere. The phytoplankton here produce half the oxygen that we breathe. This is where the ocean food chain starts. Water absorbs light, and as we go deeper, the water soon becomes darker and more blue. Here, we enter the twilight zone, mesopelagic zone, at about 200 m. There is light here, but not enough to power photosynthesis. As the light fades, we see the first flashes of bioluminescence. The biomass of the fish in the twilight zone is believed to be as much as, possibly more than, the rest of the ocean combined. As we descend deeper, the last faint blue light from the surface disappears, and the water becomes completely dark. Well, maybe not completely, because down at these depths, bioluminescence really comes into its own. This eerie and alien-looking light, mainly blue. We are 1 kilometer down, in the perpetual darkness of the bathypelagic zone, the midnight zone. This is by far the largest habitat on Earth, covering more than half the planet's surface. Yet we still understand very little about it. As we go even deeper, strange-looking creatures begin to appear. Some have enormous eyes to enable them to see. Some go to the other extreme and have almost given up on using sight. Instead of sight, most species use a series of pressure sensors that detect anything that moves. The best-known animal using light to attract prey is the anglerfish. The largest eyes of any animal on Earth are those of the giant squid. There is a tendency for species to grow larger in deeper water, a phenomenon called deep-sea gigantism. We have now passed beyond the bottom of the midnight zone, and we have entered the deepest of the ocean's waters, the Hadal Zone. It is named after Hades, the Greek god of the underworld. As well as being dark and under immense pressure, the temperature here is always close to freezing. Currents of cold water flow across the bottoms of the ocean through these deep trenches from Antarctica. There is more life here than in the open water. Our lights pick out sprawling mats of microbial ooze on any rock formations. These are microorganisms that use dissolved hydrogen sulfide from the volcanic activity to power a process known as chemosynthesis. This makes use of energy from chemical reactions to support life, instead of the energy of the sun. These microbes themselves become a food source, and so the cycle of life begins. The only other food supply is whatever scarce organic matter floats down from above. The main scavengers at this depth are giant amphipods. Here we also find Mariana snailfish and cusk eels, the deepest known fish on Earth. The word known is the key part of that sentence, because there is so much that we don't know. As we leave this higher level of the trench floor and descend a further 3 kilometers down, this effect becomes even more pronounced. There has been so little meaningful exploration. 27 people have visited the Challenger Deep. Most of these dives have been little more than extreme tourism, with little scientific value. Tying a dead fish to a pole in front of a camera merely raises the question, what are we not seeing? Why do we still know so little about an area that covers more than half of our own planet? What secrets remain hidden in the darkest depths of our oceans?